Hi everyone, welcome back to our chemistry class. So this video is still about chapter 3 periodic table. So this is a video for part D, periodicity. So in this video we will be talking about the variation of radii of isoelectronic species. So what is actually isoelectronic species? So isoelectronic species is atoms or ions with the same electronic configuration because the number of electron is the same. So for an example, we have sodium ion with the electronic configuration 1s2, 2s2, 2p6. Also we have fluorine ion with the electronic configuration 1s2, 2s2 and 2p6, and also we have neon atom with the electronic configuration 1s2, 2s2, 2p6. So the sodium ion, the fluorine ion and also the neon atom is what we call as the isoelectronic species because they have the same electronic configuration and the same number of electrons. So the word iso from isoelectronic means same, while the word electro means electron. Because it is a species, so isoelectronic species can involve cation, anion, and also neutral atom. So within the isoelectronic species, the more positive the charge, the smaller the species, and the more negative the charge, the larger the species. So this is what we call as a tips to remember about the isoelectronic species. Let's take a look at the first case. The more positive the charge, the smaller the species. So let's take a look at the positive ions there, in which the charge for each of them is positive 1, positive 2, positive 3, and also positive 4. So in other words, positive 4 is the most positive charge in this case. Next, let's take a look at the electronic configuration for each of the ions. So as we can see, the electronic configuration for all the ions is the same, meaning to say they are the isoelectronic species. Next, let's take a look at the proton number. So as we can see, the proton number is increasing, but the number of electrons remains the same. When we look at the Z value, okay, so we can see that the Z value also increasing. Lastly, let's take a look at the size of ionic radii. So as we can see there, the more positive the charge, the ionic radii becomes smaller. So when we look closely, when the proton number is increasing, okay, the Z value also will be increasing, causing the ionic radius become smaller. So to explain why within the isoelectronic species, the more positive the charge, the smaller the species, we are using the pisas. So as you can see, from the sodium ion to magnesium ion to aluminum ion to silicon ion, okay, the value of the positive charge is become more positive and they have the same electronic configuration. So your explanation must be start with the word they are isoelectronic species and have the same number of electrons and the same electronic configuration. And then kamu sambung itu explanation because the number of proton is increases from sodium ion to silicon ion. Therefore, the ZeV value also will be increasing. This will cause the force of attraction from nucleus to the remaining electrons is stronger. Therefore, the ionic radius from sodium ion to silicon ion will be decreasing. So we are using the PISAS. Next, the second case is when the isoelectronic species involve the negative charge. Okay, so the more negative the charge, the larger the species, ataupun dalam erti kata lain, the less negative the charge, the smaller the species. So as we can see there, the negative ions that we are using is P3-, S2-, and Cl-. So the value of the negative charge is -3, -2, and -1. Please bear in mind that -3 is more negative and -1 is less negative. So let's take a look at the electronic configuration first. So when we look at the electronic configuration, we can see that the electronic configuration is the same for all of these negative species. In other words, this negative species is what we call as isoelectronic species. Next, let's take a look at proton number. So as we can see, the proton number also increasing, but the number of electron is the same. When we look at the ZeV value, we can see that the ZeV value is also increasing. Next, let's take a look what happened to the ionic radii when the negative charge become less negative. So as we can see there, when the negative charge become less negative, the ionic radii also will be decreased. So mari kita tengok explanation within isoelectronic species kalau ion kamu itu bercharge negatif. So the ayat yang di sana cakap the more negative the charge, the larger the species. Tapi di sini perbandingan yang saya gunakan adalah the less negative the charge, the smaller the species. Sebab apa? Kalau kamu tengok, saya susun isoelectronic species itu daripada -3, -2, -1. So dia daripada more negative kepada less negative. So seperti yang kamu lihat, dia punya electronic configuration adalah sama. So dalam erti kata lain, semua spesies itu adalah isoelectronic species yang mempunyai bilangan elektron yang sama. So daripada P3- kepada Cl-, the number of proton will increase, and also the ZeV also will increase, causing the force attraction from nucleus to the remaining electron is stronger. Therefore, the ionic radius from P3- to Cl- will be decreasing. So untuk explain ini juga kita akan guna pakai PISAS. Next, kita akan tengok the variation in the ionic radii across period 3. So, ini adalah ahli-ahli untuk period 3. So, bila kita tengok daripada Na plus kepada Si4+, okay, the ionic radii among the cations will be decreased. Sama juga kalau kita tengok daripada P3- kepada Cl-, the size of the ionic radii pun akan decrease. So macam mana kita mau explain sebab dia decrease? Kita akan gunakan PISAS. Lepas tu bila kita tengok pada Si4+ dan juga P3-, dia ada large increase in radius di sana. So large increase ini adalah disebabkan oleh dia punya number of shell berbeza. So untuk explain large increase itu kita akan gunakan NSAS. So slide ini menunjukkan full explanation why the variation is happening in the ionic radii across the period 3. So please bear in mind the last sentence there, the trend in ionic radius across period 3, okay, ianya akan bermula daripada P3 minus, S2 minus, Cl minus, Na plus, Mg2 plus, Al3 plus dan juga Si4 plus. Meaning to say P3 minus paling besar dan S4 plus paling kecil. Next, let's take a look at the variation in the ionic radii across period 2. So, ini adalah ahli-ahli bagi period 2 daripada lithium pergi neon. So, as you can see there, the ionic radii, okay, will have decreasing trend from lithium to carbon and also from nitrogen to fluorine. So, to explain, okay, this variation, this trend, we are using the PISAs. Next, as we can see there will be a large increase in radius between the C4 plus and also N3 minus. So, to explain this trend of increase, we are using the NSAS. So, this slide, okay, shows the full explanation how and why the variation in ionic radii is happening across the period 2. And please bear in mind the trend in ionic radius in period 2, okay, will start at nitrogen and end with carbon. So that's all for now, guys. Thank you for your time and I'll see you in the next video. Take care and bye-bye.